Well, hey, welcome back. I mean, you've had an entire week away from one of these lovely videos, unless during the break, of course, you were watching these, which would have been so wonderful. Today we're going to kind of come back to the products of decimals, talk about patterns and things that we're seeing, kind of understand the why and the how to like make sense how to solve all the different ways we might run into multiplying decimals. So, of course, as always, you know me, I like to break down some vocabulary. So, as we start today with this concept of products, right? Remember, product itself is the answer to a multiplication problem, right? And then, of course, decimals, those are the parts of wholes. Remember that a decimal is a part of something. There can be whole numbers with decimals, all right? If we looked at this first example over here of 4, which is a whole number, it has no extra parts to it, 4 wholes, times 2 wholes and 1/10, right? And this right here is the decimal part of it, the 1/10. That is a part of a whole, right? It is taking the number, technically, it's taking the number 3 and breaking it into 10 pieces, and then we only actually have 1/10 of that whole. It's only a part. Okay, so that's where we kind of think about what this concept is. And then we're learning more things about decimals. Like we are learning about how things change and understanding the multiplication of things with decimals, which is very interesting, right? Because if we go back to the history of multiplication and we say something, I have 3 times 4 equals 12. Well, what we notice is that when we take 3 and we multiply by 4, we get 12, which is a larger value than either of these numbers. Like that is a fact. And that happens with whole number multiplications. What happens over here is a little interesting because if we have something like this, right, this is 2 and 1/10. Maybe I'll erase. Oh, wow, there's that thing. It's so funny how that happens. There we go. We're talking about multiplying 4 wholes times 2 wholes and 1/10. Well, actually, our product is going to be larger than 4. That makes sense, right? It's going to be larger than 4. Just like here, 3 times 4, well, 12 is going to be larger than the 3 we started with. And that makes sense because 4 wholes times 2 wholes is 1 whole, and then there's the extra 1/10, which we can talk about. But that's not really the point right now of the answer. The point is understanding the system. Now, if we look at something like this is where it changes because this value is less than 1. So if you're going to be less than 1, then actually your answer is going to be smaller than 4. Not 1, but smaller than this 4, smaller than the start here. And that's one thing now we're seeing is that when we multiply by values that are less than 1, this is less than 1. Look, there's nothing in the ones place. There is no wholes. We actually get a value less than the number we began with. And we could prove that mathematically. And of course, now I have to do that. Oh, don't do that, computer. All right, go here. I'm going to erase this stuff over here. And we can prove that fact mathematically because we could treat this as a repeated addition problem, right? We have 4 8/10. So I'm just going to line up 4 of these. And 16, 24, 32, right? The decimal comes straight down. So 3 2/10, which is, look at that, it's smaller than 4. So when I take 4 and I multiply it by a number smaller than the value of 1, then I actually end up with a smaller value than the number I started with, which is crazy, right? Because then we move into this other aspect where I have 2 numbers that are less than 1. And when I multiply that, I'm actually going to be even smaller. We could even say smaller than 1. It's actually even going to be smaller than 5/10, which is wild. And we saw that with all that shading that you absolutely adored doing. But this is where we have to start thinking about it and understanding decimals and understanding like what are the products? Where does it make sense? How do I use the techniques that I do and move on from there? So today we're going to dive deeper into that. So although that was a long introduction, we are going to dive deeper into this concept and be thinking a lot about what do we do with certain problems when we have to multiply? So I'm going to take the first problem we have today, and let's say we have 9 and 3/10, and we're going to multiply that by 4 and 1/10. Now, this is the first time we've really had to think about multiplying two decimals together. So let's do a little thinking first. One thing we can analyze and make sense of is that, well, both of these are whole numbers. So I do understand now that I'm not going to get an answer smaller than 9 because technically I'm just multiplying 9 times 4, right? If this was an estimation. And I would know that I have about 36 holes in my answer, right? So that's going to help me. From there, we have to start thinking about what are some other techniques. Like the estimation really works well for here. So when I go ahead and do that estimation, the next thing I'm going to do is I'm going to treat this. And I feel like this is where some of us are getting lost. So I'm glad we're going back over this. I'm not going to treat this as 9 and 3/10. I'm actually going to treat it as a 93. I'm not going to treat this as a 4 and 1/10. I'm going to treat it as a 41. And the reason I'm doing that is that I'm actually just thinking about not place value right now, but just the overall digits. Like, what do I get when I multiply? Now, I can think about place value later because I have a really good estimation that will help me out. So, I don't know. Let's do an area model for this. I haven't done an area model in a while. So, I'm going to expand these out. I'm going to build my area model. I have 90 and I have 3, right? That's the columns. And then I have 40 and I have a 1. Those are my rows. And now I'm just multiplying. So this would be like 90 times 40. And this would be 3 times 40. And this would be 90 times 1. And this would be 3 times 1. So let's see, 9 times 4 is 36 and 2 zeros. 3 times 4 is 12 and 1 0. That's 90. That's 3. Okay, so we're going to have to add these values up. So 120. Now again, right, I'm just treating this like there are no decimals, and that's fine. We've seen this actually in our homework where the digits stay the same. It's actually the location of the digits that turns into the trickery. So if we now go back to our estimation, well, what we notice is if it's about 36 holes, well, that would make sense then to put our decimal right here so that we have 38 holes, because that's a lot closer to 38 or 36, right? It would not make sense to call it 381 and 3/10 because, well, again, that's not close to 36. That's like 10 times greater, in fact. So that's something we can do as we start to see decimal times decimal. We can pay attention to that, like that estimation works. But also we want to start looking for patterns because sometimes estimation gets a little more difficult. And I'm going to talk about that with another example of something where maybe we're multiplying. And let's talk about that right now. I don't know why I said I'm going to and then not show you. If we had something like, let's see, let's change the color. If we had like 3 and 2/10 and we're multiplying that by 6/10, right? So if we dive into this process, this is where the estimation gets kind of difficult. It also makes it very difficult to do repeated addition because I actually can't, this isn't a whole number, right? So it's not like I could do 3 and 2/10 6/10 of a time. That doesn't really register. I also couldn't write 6/10 3 and 2/10 times. I could do it 3 times, but I don't know what 2/10 of this 6/10 is. So that wouldn't really make sense, right? So that's where, you know, the repeated addition has been helpful in the past when we had a whole number in a decimal. But now that I have a decimal and a decimal, we're going to go back and like start from the beginning. I have to go back to what I'm thinking. Now, again, there's estimation in here. This one always gets a little difficult because if I round this to 1, well, 3 and 2/10 times 1 is 3 and 2/10. I don't know if that will help me find my place value. I also know that my answer here, because this is less than 1, I know my answer is actually going to be less than 3 and 2/10. That's some of the pattern we've seen is that if I multiply it by 1, it's going to be 3 and 2/10, but it's less than 1. So my answer is actually going to be less than 3 and 2/10. So again, I don't know if rounding this to 1 helps me know the place value. If I was to round it to 0, well, that does me no good at all because I'm going to have 0. And I don't know how that will help me see where to put my decimal. So this one gets a little tricky. What I'm going to do, since I don't really have an idea yet, is I am going to do what I know. And what I do know is that even though I don't have a great estimation, maybe I could look for some patterns. And maybe what I could do is multiply, like we did in the last example, where I just treat this as 32. I'm going to treat this as 6, and I'm just going to multiply those first. So let's do that step. I'm going to use partial products this time. So 6 times 2, and then 6 times 30. So that's 12 and 180. So that gets me 192. Okay, so again, right? Thinking about, we know it's got to be less than 3. So I guess in this case, it would make the most sense to put my decimal here. But what I don't know is actually, does it actually belong here? Do I have something that's less than 1? Or do I have something that is like almost 2 wholes? Like, that's what I'm saying. Like, guessing this works to me. Like, this seems reasonable. But again, we don't know unless we start to look at patterns. So I'm actually going to go back to that first problem to think about patterns. And if we look at this first problem, here's a pattern we start to see. And we'll look at this in other examples. I didn't want to do like 10 examples and then have you look for the pattern. That would have been better, trust me, because the more examples, the better. But if we look over here, this problem here has 1 decimal place value in it, right? It has a tenths place. And this over here has 1 decimal place value over here. So when we think about that base 10 work, we're always looking at place values, and that helps. The number of zeros in 1000 helps me think about how many place values I need, right? Where I need digits. Well, it's actually the same thing here. If I have 1 place value here and 1 place value here, technically that means I have 2 decimal place values. And if I actually go back and look at my product, my answer, where we use estimation, you notice I have 1, 2 place values here as well. And so one thing I can start to notice is that I can look at the place values of my original numbers that I'm multiplying to help me figure out where the decimal goes. If there's 2, then I have 2 in my answer. So if we go to this example, let's think about that theory. There's 1, 2, and then 1, 2. So that would make the most sense because actually I can just start counting decimal place values. I know that's like a, what moment? And don't worry, because we're going to do 2 more and kind of think about this process. So let's go back into this next one. Let's say we have 7/10 times 1 and 9/10. So what I'm saying now is that instead, now that I'm multiplying decimal by decimal, instead of going straight to estimation, I might just say, oh, well, I have 1 place value here and I have 2 place values here. I'm only talking about the decimals, right? I have 1 here and 1 here. So grand total of 2 decimal place values. That's all I'm looking at. Place values. Which tells me that when I have an answer, I should actually have the same amount in my product. I should have 2 in my product. So I'm going to go back to this technique where I can just treat this as a 7. And I'm going to just treat this as 19. And I will multiply those. I will use standard algorithm this time. 63, 7, 13. So when I multiply these together, I get a grand total of 133. But now it comes down to, well, no, it's not 133. It actually is a decimal. And because of what I had, I should have 2 place values in here. So I'm going to go down here and I'm going to think 1, 2 spots, which means my answer is 1 and 33 hundredths. Sorry. So that is what we have in this case. of how I might be able to now, when I have a decimal and a decimal, I'm not sure what to do. I can actually just start to count place values. Okay. Now, I want to lead this to one more thing that we'll talk more about tomorrow, but this is actually really cool because now knowing this, I'm actually going to treat this last problem with all the things I know about multiplication. So 12 and 6/10 times 2/10, right? So now what I'm going to do, which is like thinking that same theory, is what happens if actually I think about treating this in the terms of using an area model, right? So if you first think about that, I'm going to expand this out. This becomes a 10 plus a 2 plus a 6/10, right? That would be the expanded form. And we'll call these my rows. And then come over here. Well, this is just 2/10. I actually don't even have to expand that. And that's my column. Great. So now we can build our model. And I have 1, 3, right? I have a row of 10, a row of 2, and a row of 6/10. And then I have a column of 2/10. And so now we can actually just start to do that multiplication. And this might be a little more complicated, but it's good practice because we're thinking about what we've learned. Like this is a base 10 problem. So actually, this is getting 10 times greater. So my decimal is just going to jump over 1. So that gets me an answer of 2. 2 times 2/10. Well, I know that's going to be less than 2. So I can just do 2 times 2 is 4. But there's 1 place value. So I have 1 place value. So that actually equals 4/10. And then this is 6/10 times 2/10. And we learned this with the modeling that, again, I'm going to be in the hundreds, but again, that's why. Look, I have 1 place value, I have 2 place values. So 6 times 2 is 12, but then I need 2 decimal place values. So that'd be 1, 2, decimal goes here. So that's, I'll rewrite it here, 1200s. And so now that I have these, I'm going to do that in a different color so it doesn't get confusing. These values, I can add those together. So 2, and that would be 2 and 0/10 to help me out, plus 0 and 4/10 plus 1200s. And this is where that gets tricky because look at where we have to do all of that decimal place value. That's where I have to line everything up. And what that's going to get me is 2 and 5200s. And again, and again, and again, and again, if we go back, and I'm actually going to do this one last time, and then I promise we good. But if we go back to what we were learning today and thinking about, oh, well, also I could just say there's 1 decimal place value, there's 2 decimal place values, therefore there should be 2 in my answer, and they are. We could actually go back and see how that works again with not using an area model, but just multiplying. I'm going to use the same problem. So we already know the answer. 12 and 6/10 times 2/10. So 12, 6/10 times 2/10, and then that equaled 2 and 5200s, right? So we already know that, but what I'm saying is, what if we had treated this like, hey, this, I'm not going to expand, I'm just going to call it 126. And what if we just called this 2? We multiplied those, so 126 times 2. Let's see, 2 times 6, that equals 12. 2 times 20 equals 40. And then 2 times 100 is 200. And when you add that up, you get 252, right? 252. And then if I'm questioning where the decimal goes, again, I'm just going to use that technique we're kind of looking at today. 1, 2 decimal place values, 1, 2 decimal place values. So there's actually all sorts of different ways we can do this. And that's what today is about, is like really being flexible with making sense of like, how am I going to figure this out? How do I put this work down? How do I make it work? And then how do I ask the questions when I'm not sure? Is it estimation? Is it repeat addition? Is it understanding that, again, because this is less than 1, my answer will be less than 12? which would also be very helpful because think about that. If I can't stop. Sorry, I can't stop. This is so awesome. If I had put my decimal here, well, that's 25 holes, and 25 is way larger than 12 holes. And that would make sense because this is less than 1, and my answer needs to be less than 12. So, like, there's all these things that I can start thinking about now with math and multiplication of decimals to help me through it. So, I'm going to leave you at that. Get on the practice buddy. The questions will be straightforward. It's really the scratch paper today. It's like, what are you doing in your journal and what are you doing on scratch paper to make sense of it in order to get that accurate answer, right? Use estimation. Use the technique we talked about today where you're just counting place values and putting it back in. Ignore decimals and multiply as the whole numbers, but then put them back in. Maybe you're even like, whoa, wait, this kind of makes sense. And you want to try this area model technique. Whatever it may be, challenge yourself today to learn. And as you walk out of the process, being like, oh, yeah, this is starting to make more sense. So with that being said, I appreciate you. Keep up the good work, and we will see you later.